I think the next talk is also on teleconnections from Adnan Abid, and he will, I think, mostly focus on the European sector. So can you please share your screen and start your presentation? And try to keep it to 15 minutes for everyone else, so we keep up a little bit with the time. Abid, okay, good. You can't hear you. Okay, very good. I can hear you.
Yeah, so you can hear me, right? Yeah.
Yes. Yeah.
Very much, Andreas. It was a very nice talk, and I think the way you stopped at the end, I may start from there. That ENSO has some kind of a tropical interbasin connections. So, one of the important connection is in the Indian Ocean region. So here we are trying to emphasize that for the European sector, this kind of forcing coming from the different tropical ocean could explain the prediction scale, which is actually quite low for the European region in different systems. I would like to thank my co-authors in this case who have really contributed to this work. And okay, so just to overview that in European climate, it is actually mainly affected by the North Atlantic Oscillation. And North Atlantic Oscillation has two phases. One is the positive phase, and another is a negative one. In positive phase, we have a kind of a strong gradient of the Icelandic low and the Azores high, which actually respond. And then when it weakens, we get a kind of shift in the storm type, which moves more on the eastern side. And this actually explains that there is a kind of and how this is linked with the external forcing, which is being dominated by the ENSO signal, mostly because on the seasonal time scale, ENSO is the main dominant force which drives the internal variability over the global part, as shown by the Andrea in different parts of the globe. So there are different point of views that NEO has a kind of time scale which may differ from month to month. If we look at the monthly daily connection with the SST. So there's a paper by King et al. In which they have explained that if we just take a 3.4 SST and regress over each month separately, and in this case there's we will found that there is a change in the circulation pattern from November to February, which is actually starting from the late fall to the to the late winter part, and they have proposed several mechanisms which can explain these changes in the circulation. One of them is that how this is being changed, how circulation anomalies are changes through the ENSO transition from early to late winter, and there could be a role of interbasin teleconnection in this case. So already this means that ENSO might not have a kind of persistent signal throughout the boreal winter, which can explain this kind of a transition. So most recently there is an article by Adam Scaffe, who has shown that and if we just take these three tropical regions are mainly can be adopted. And if we can look at these three regions, they are highly correlated with the NEO index over this region. And if we just correlate this case with, if we just take a rainfall of this from these regions and correlate with the NEO circular correlation, and we found that this means that NEO has a negative correlation with the Pacific region, and it has a mixed kind of a signal with the Indian Ocean, and similarly with the positive signal coming from the Atlantic part. So, and this is very well explained in most of the, and either you just take a kind of 1 month, a kind of a lead lag correlation, taking a rainfall from the December and doing it kind of January, February, and then also taking a simultaneous correlation, you still get a similar region which can explain your this. In fact, there's also a tropical Western Pacific. So if we just construct the model kind of based on these four predictor for the NEO predictions can improve, which they have shown in the article, so reach to 0.65 in this case. So, but still in this case, there is not a kind of segregating a season from early to late winter. They are taking a kind of a DGF mean in this case. So later on, there is a paper by Blanca. She has explained that Okay, ENSO may have a different teleconnection from starting from early to late winter. So what they have shown that if we just have an ENSO building it here, somewhere here, that if we just make a kind of a regression, it has a secondary sector which is coming, or which is identified over the Gulf of Mexico and Caribbean, which is it acts like a secondary to the ENSO forcing, and it acts as a velocity wave source for the Atlantic region, and acts as a during this case. So this means that in early winter, it should have shown that the answer it does not have a direct signal to the Atlantic sector, but it is coming through the Gulf of Mexico. So we have actually, based on this case, we have adopted this data set, and then because in this case they have explained that the this initialized simulation, which are actually the seasonal forecasting system, can explain this kind of mechanism, but in the uninitialized simulation, does not exhibit this kind of behavior. So we try to get this through ready in this case, and then we adopted the initialized simulation from ECMWF and the uninitialized simulation for the model from the different models for the 20th century. And then we did a regression over this case. This is the monthly regression of Nino 3-point index, simultaneous regression of Nino 3.4 SST index over the geopotential height. And you can see that there is a changes in the circulation pattern happen from late fall to the late winter. And similarly, if we just correlate the monthly SST to the global rainfall, there is a pattern appear in the Indian Ocean, which is kind of an eastern-western gradient pattern, where the Western Indian show the positive correlation and the Eastern Indian show the negative correlation. And this pattern actually weakens as the season progresses, and it becomes almost vanished in the February season. And this could be related to the kind of a seasonal cycle of the rainfall, which is very strong in the Indian Ocean in this case. So we are looking that it becomes like a classical PNA in the late season. So we just picked up these 2 months in December and February, and then considered that why this season changes happen with this kind of, because in this case the maximum tropical interaction happens for December in December, and the weaker one happens in February. So we picked up these two extremes and look at the thing. So we define the two index, one based on the rainfall, for the Nino 3.4, and another is for the tropical Western Eastern Indian Ocean. And then regress those index over to the geopotential height anomalies, and we found that if we just take a Nino 3.4 precipitation rate, we get a kind of a positive and like a pattern in the Atlantic sector to the European sector, and similarly we get a kind of negative like pattern in the late winter. But if we just take a Indian Ocean index and regress it over this case, even we get a stronger pattern in early winter compared to what we have in with the Nino 3.4, and there's not much change in the late winter part for the Indian Ocean index. So, and we in fact checked this case for the seasonal 5 data set also. In this case, that for each for the each ensemble member separately, and this has been shown for the ensemble mean. And we get a kind of a similar response that the early winter we have a kind of a strong positive annual response, and a weaker, and the late winter we get a negative annual response. So there is a change in the state for the changing of the ENSO teleconnection. So to get the figure out that what is happening in this case, which basin might be dominant to the other in this case from early to late winter, we did a partial regression, and in this case, where if we remove the Indian Ocean rainfall anomalies from the global anomaly and then re-regress the Nino 3.4 index, you can see there is not much signal over this case, and it is weakened pattern appear in the North Atlantic sector. And then if we just remove the ENSO signal and re-regress the tropical Western Indian Ocean, we get a strong response in the Atlantic sector, and also the subtropical jet is quite strong here. So we found that this could be a link in this Indian Ocean anomaly, which is happening in the Indian Ocean dipole anomaly, which is happening in the Indian Ocean, which is forced by the ENSO over here, and then In fact, if we just look at the late part, there's not much signal appear in this case. So to get to look at this causality relationship, we performed numerical experimentation where we just forced the mid-tropospheric pattern with this heating and diabatic heating anomalies here, which is kind of a western eastern dipole, appeared like an observed pattern, and then run the simulation starting from each October till next 6 months, and we perform 114 sample members in this case, and we got a similar response of a rainfall as appeared in the observation. And this is a wave train happen here. It shows that that there is a subtropical jet stream being excited by this wave pattern, because what happened with this wave pattern, we get a kind of an upper level convergence here, and then we get an upper level divergence here. So which enforces this minima to its best, and this appears to be a source of the wave train coming to the North Atlantic in this region. So this is a kind of a consistency which what we have observed with the observation in this case. So the MOD experiment has reproduced this kind of a circulation in the early part of the winter in this case. And and then later on, we are now trying to test the model with the kind of that, okay, we get this behavior in the observation, we get this behavior in the kind of seasonal handcast data set, forecast data set. So does this behavior exist in the CMF5 models? So for the CMF5 models, based instead of a kind of a couple model rainfall, we took an index based on the omega field in this case, which is a proxy for the rainfall in the models. And then we're doing the similar thing in this case and found a similar kind of a transition from early to the late winter, which is coming from the positive NA to the negative NA part in this case. And then we looked at that how much the diversity in the model is there from one model to model, and we can see that in the model in December part, we see a large spread in the. This is actually what this is the area average regression coefficient of the model for each model separately, and the black is the kind of observation, and all of these are the model which are mentioned here. So what shows that there is a large diversity of the model in reproducing this teleconnection in early winter, but in late winter there is a kind of the spread is low, because I think this could be the case that the models are very much able to reproduce the teleconnections, direct teleconnection, which is in February we had a direct ENSO teleconnection to the region, but in early part there is a kind of interbasin which is playing a role, and most of the model might have does not have this kind of behavior in this case. And this is also being shown by here, that if we just took a special correlation of this case, that is most of the models are getting it wrong in the early part of this of the winter. So of course this means that there's a need of the model to revisit this kind of teleconnection if they want to get the teleconnection right, and this could be important for this case. And then we just composite the model, which have a good versus bad, and you can see that there's a kind of a good region and there's a poor region, and where they have a better dipole, we get a better teleconnection here, and similarly the bad one get the bad one here. And this is my schematic diagram, which explains that we get a kind of when we have a dipole here, which is forced by the ENSO, it explains the upper level convergence compensated by the divergence, and explains the South Asian jet, which acts as a Rossby wave source for this case, which is only happening in the early winter. But in late winter, this is not very much effective, because we didn't get a kind of a Western Indian Ocean response from the ENSO in this case. So it has only a direct teleconnection in the late winter, and that's why the most of the model is getting it right in late winter compared to what has this case. So my main message is that we need to revisit teleconnection in terms of the interbasin connection, because this might be the key in getting the improvement of the model, because most of the model might are getting the signal for the ENSO right, but might not be able to get this for this interbasin connection right. So I think this is my talk, and thank you very much. So this is our paper.
All right, thank you.
Thank you very much.
Yeah, thank you very much, Adam. We have time for one or two questions. So if anyone wants to raise their hand or just unmute yourself and then ask a question.
I do have a question. First of all, thank you for your nice presentation. So in your numerical experiments where you prescribed the Indian Ocean dipole, are both poles of the dipole important for the teleconnections, or like the eastern or western tend to be more influential?
Okay, actually, I think both are important in this case, because if you look at the observation in this case, just to look at the observation, you can see that we are getting a kind of ENSO force or dipole response both on the eastern and western Pacific. And when this becomes weakened, it just get a monopole in the eastern Pacific or eastern Indian or western Pacific region. But and it does not have the wave plane to get the right in this case. So that's why I think the both are important in this case, because they kind of produce compensating each other effect in the Indian Ocean, which is enforcing this subtropical jet over the region, and this is not being produced in the late winters. So that's why I think both are important.
Yeah, thank you.
Yeah.
Anyone else? I think Paloma had a question. I think I'm just reading it from the chat here, or maybe Paloma, you want to say something? Or?
Hi. Yeah, thanks for the talk. Very interesting. It was just more or less the same question. It's just the mean state of the Indian Ocean. So if the phase of the Indian Ocean dipole matters for this teleconnection, do you think it would be the same in both phases? Thanks.
It could be. I haven't checked the different phases in this figure. I have to check that part. Yeah.
Or maybe I have a related question. So you are saying that the ENSO teleconnection to Europe is done over the Indian Ocean. Is that
in early part?
Say again?
In early winter.
In early winter.
Yeah.
So it is a combination of ENSO and the Indian Ocean. So to me, this raises the question: is can the Indian Ocean do it by themselves? I mean, is the Indian Ocean has intrinsic variability that would create teleconnections to Europe by itself, or can it only be together with ENSO?
Yeah, I think it could be. It could be because this Indian Ocean this dipole can exist independently also in this case.
But do you have evidence that it happens independently? I mean, do you have some kind of evidence that shows that independent of anything, any significant SST anomalies in the Pacific, that there's something happening in the Indian Ocean that does have a teleconnection to Europe?
No, of course, they are not SST based. It's just a rainfall based index. If you just look at the SST point, SST might not have any teleconnection. Let it be. I mean, it's just the SST. The Nino 3-point forcing is getting this rainfall dipole here in this case. So I think this evidence is like from this partial regression that if we just remove the Indian Ocean, we're getting a teleconnection, right? So it could be existing independently also from the ENSO part also.
All right, thank you. Okay, Eric?
Can I ask a last question, Dietmar, if you allow me?
Okay.
Yeah, thank you very much for this presentation. So there are studies showing that intra-seasonal teleconnection between the Indian Ocean and the Atlantic are going westward instead of eastward, what you were showing. Like, for example, Christophe Cassou's paper making links with the higher frequency, the MGO and weather regimes over the North Atlantic. Do you think that can play a role in these teleconnections, looking at the the higher frequency parts of your signal?
It could be. I haven't looked at that, but could be the case. I need to check that case.